Greetings everyone. Today we're going to explore solving systems by graphing, but in this particular video we are going to need to isolate y, and we're going to have infinite many or no solutions. So it's a very specific video. Make sure the title matches what you're looking for, otherwise see my YouTube playlist. Now, a quick refresher based on the previous videos. Remember that a system of equations states that there are multiple equations, and in this series we're going to stick to 2 equations. In this particular video, we're also going to concentrate on parallel lines, which create no solutions because they never cross. And when we graph the same line, that solution is infinite many because the lines cross forever, infinitely. We're going to jump straight into our examples. We do have a folder before this, which will make it easier due to the graphing. I'm going to start off with this first equation. Now I don't have space to solve for y, so I'm just going to rewrite it here. As with all of our previous lessons, our first goal is to isolate y. Now I'm not going to spend time going through why I'm doing these steps because we've got plenty of other videos and lessons that we've already done for that. What I want to concentrate here on, 2 divided by 2 is 1. Negative 1 divided by positive 2 doesn't divide nicely, so we're going to leave it as negative half. What this does is create a beginning value, a b value of 1. We begin on the y-axis, and we have a slope of negative 1/2. So we think of it as rise negative 1, run 2. Down 1, right 2, down 1, right 2, down 1, right 2. So we connect those dots, draw our arrows, and let's see what happens on the next one. I'm going to rewrite it over here so I've got some space to work because I need to isolate y. I'm going to subtract 2x over first. Again, if you're still struggling with isolating y, see those videos on my playlist. Our goal here is to get to the point where we can graph it. Now you'll notice 2 over 4, it's got a negative sign. 2 over 4 reduces down to 1 over 2. We always reduce fractions or divide if possible. That means I'm going to begin at positive 2. I'm going to go down 1, right 2, down 1, right 2, down 1, right 2. So you'll notice that we have the same slope and our lines are so close to each other, but they're never going to cross. It's the key thing we notice here is they have the same slope. See that negative half m, negative half m? And we notice that they have different beginnings. When 2 lines have different beginnings and the same slope, it will always be no solution. No solution because they'll never cross. See that negative sound? No, never. All right, let's try another one. On this one, I'm going to rewrite the equation over here so I have some room to solve. My goal is to isolate y. So I'm going to add x first. And by doing that, y is already solved. I'm going to have 5 plus, technically there's a 1 in front of the x, so I'm actually going to write that. That means I begin at 5. 1, 2, 3, 4, 5. And my slope is 1. Rise 1, run 1, rise 1, run 1, rise 1, run 1. Now, I tend to do more dots than necessary on the first one. If you have a straight edge or a ruler, of course, that would be even better. Let's take a look at the second equation. My goal is to solve for y. I currently have a plus 2, so I'm going to minus 2. The y falls down and I have x minus 2. So I'm going to begin the number by itself at negative 2. Again, if you're struggling with the m and the b, see my other videos. We're going to have a slope of 1. Now listen to that pattern. Slope of 1, slope of 1. They have different y values, right? Different y-intercepts. So this is going to make sense. We've got parallel lines because they have the same slope and different y-intercepts. So similarly, we have no solution. All right, let's take a look at example 3, and I have a quick favor for you to ask. If these are the two equations you see on your paper, can you please change this 8 to a negative 12? So that's a quick fix. That's a typo on our part. You might have a new one that has the negative 12. All right, let's begin. This first line, you guys, I don't need to solve for y. I'd have to distribute a fraction, and guess what? I can avoid that. I can avoid that because this is already in point-slope form. If you need to see my point-slope form videos, please check those out. But what that form tells me is that my starting point, if it says x plus 2, my x value is negative 2. If it says y minus 2, my y starting value is positive 2. So I begin at negative 2, 2. That's my starting point. Now from there, my slope is still located in the same area in front of the x. My slope is still a positive 1/2. So we're going to rise 1, run 2, rise 1, run 2, rise 1, run 2. I always like to do extra dots. If you have a straight edge or ruler, that would be better. As you can see, I do not with my tablets. That's a little crooked. Let's take a look at the second equation. I have to solve for y. I'm going to minus the 2x over to the other side. The negative 4y falls down, and I have a negative 12 minus 2x, thanks to that change I made. We're going to divide every piece by negative 4. The y falls down. We have a positive 3 and a positive 1/2, because a negative by negative is positive. 2 over 4 simplifies to 1/2. Always reduce your fractions. All right, so I'm going to begin, now that y is isolated, at positive 3 on the y-axis. Look at that. Our slope is a positive 1/2. Rise 1, run 2. Interesting. What do you notice? We have the same points, the same slope. We're crossing forever. So I had you change that so we could make sure that you have an example of what infinite many solutions looks like, meaning every point and tiny point, exact point crosses. So infinite many solutions. All right, thanks for following along. Make sure you check out Google Classroom to see what your task is for this. We have now officially kind of looking at all 4 options. So sometimes y is already isolated. Sometimes you need to isolate y. Sometimes you get a nice pretty solution, and sometimes it's infinite or no solutions. Now, most commonly, you're going to have to isolate y, and you're going to have a mix of the types of answers. So be prepared for that coming up. Let me know if you have any questions, and until next time, have a good one.